Jeff Finley. I will be doing the Intel portion of the presentation, just doing a general memory. Where is memory at today? Where is DDR3? And why are we here? Because DDR3 is entering the mainstream area. So I'll be doing the first part of the presentation. Sylvia Kadavar from Samsung will be doing the second part of the presentation. In addition, because we have a lot of very good information, we're going to have a Q&A later tonight at 6 o'clock. So if you have questions and we can't get to them in the Q&A portion of the presentation, which might be tight, please give us the questions, see us afterwards, or come tonight at 6 o'clock here. We'll also have key companies. King Tiger will be here, Corsair will be here, and some of the register companies will be here, so we can also open it up to more key ecosystem partners to answer your questions tonight during the Q&A. So again, I'm going to go ahead and jump into the presentation, and here we go. As I talked about, I want to start off with the roadmap. Where is Intel using DDR? Where is Intel using our DRAM? Where is DDR2 going? Where is DDR3 going? So kind of first let's level set on the roadmap and where is Intel pushing the different memory speeds and feeds across the board. Then, because the presentation's on DDR3, I can't skip that today. So what and why is DDR3 important to Intel and important to you? I'm going to look at it from a desktop perspective, a mobile perspective, a server workstation perspective, going briefly over our roadmap, what is the intercept for those products, and why we're pushing those in the various segments. Okay, so now I've talked about why is DDR3 important. Now I want to talk about who are the ecosystem partners and where are they at in getting enabled so that you can feel comfortable and assured if you do migrate, which I want you to DDR3 on your platforms, that there's going to be DDR3 readily available, good pricing worldwide from all the key companies. Pass it over to Sylvia, and she'll be doing Sylvia key points from a Samsung standpoint on where they see DDR3 going. What I'd like to do, if at all possible, if you're dying for a question, raise your hand. But it would probably be easier for us is if we could finish the presentation and then hit the Q&A. Okay? Okay, so let's see, where's the laser part? You guys have seen this format from me in the past. What we've got is our DRAM, which is a technology that came out a number of years ago. It's very good for high-speed applications. We're in the process of migrating, or we have migrated off of using that technology in all of our platforms except one of our network applications. So because of the networking applications having typically a 5 to 7 year life cycle, we're going to continue to support our DRAM in that segment. There has been a move away from some of the lead companies on that, so we have worked with SMART, Samsung, and Elpida to make sure that we've locked up supply for some of your customers who are going to migrate to that networking application from Intel. So that's where we're at in our DRAM. So we've got it in one of our networking applications, and we'll continue to support that for the next couple of years. From a DDR standpoint, the industry has moved off of DDR, but we're still using it in some of our handheld type devices. In the process of both of these types of areas, the communications, handheld, and embedded, have mostly migrated to DDR2. In the case of mobile internet devices, they're migrating to low-power DDR2 as an example, LP DDR2. In the case of our main memory section, we've been on DDR3 for a number of years. We first came out with it in the desktop area, 6 months later in the mobile area, and then earlier this year in our server area with an integrated memory controller. So that platform only supports DDR3. So we've got DDR3 currently at 800 and 1067 and then 1333. Because DDR3 has been made for the last couple of years, the industry has been able to optimize and get 100% or close to 100% yields on 800. So they've actually migrated to supporting 1066 as kind of their baseline. It's become pretty difficult to order an 800 module today. So 1066 is pretty much the low-end product. 1333 is becoming the sweet spot. This year or coming up, we'll support 1600. So we're in the process already. JEDEC, which is the standards body, has already defined the specification to 1600. They're already working on 1866, the next bump up. And they're already working on low voltage. So industry is ready to go from a low voltage standpoint. Our first intercept for low voltage will be at 1.35, and that will be coming out early next year on our Westmere product that was mentioned earlier in the keynote in our server traditional DP space, where we refer to as EP, efficiency performance space. So those are the two things coming out in the 2010 timeframe: low voltage 1.35 DDR3 focused in the enterprise segment, and the 1600 peak bandwidth speed. So if you're anything like me, we have a lot of code names and product names, and sometimes I just wish I had a cheat sheet. So I thought, hey, why don't I give them the cheat sheet? So I put it here on a table for you. Desktop, I'm only showing the segments that kind of lead a memory transition. So right now, 50+% of our volumes in desktop are more in the entry, mainstream, or lower segment. But that doesn't lead a memory transition. That will typically use a Bear Lake or an Eagle Lake chipset and typically put DDR2 on it. The mainstream segment has two products, the i7 and the i5, which is the Linfield and Clarkdale. Those products support 1333 from a standard standpoint, but then we have an overclocking specification that we work with key companies in the industry to roll out, so you can push that to even faster speeds, 1600 or higher. But typically you'll see these two platforms using 1066 or 1333. On our high-end space, we came out with a product in December. We've refreshed that platform, and now we'll support 1333 and again 1600 or higher with XMP. So that's how you read this table. In our server area, we've got two products that will be coming out at the end of the year in the mission critical and expandable. Most of you guys know that as the 8-way or 4-way space type products. They will support a buffer on board product, which for those of you familiar with FBDIMM, it had the buffer component on the DIMM itself. We've pulled that buffer component off and allowed customers to put it physically on the motherboard, thus the name buffer on board, or BOB, that you might hear. Both of these products will use the BOB architecture. The high-end Itanium one has speeds, because again, speed isn't as important. It's a lot about capacity. Will support up to DDR3 800, and the EX product will support up to 1066. Again, both those products are coming out later this year for mass volume production early next year. In the EP product, we have the Tylersburg EP product already today. We'll be refreshing that platform with the low voltage version early next year. And then in our entry space, we use a derivative of the desktop product, and that product shipping now, and it supports up to 1333. So again, it's just kind of a cheat sheet to show you what the code names were if you're like me and use the code names, or the actual product names in the industry. What is DDR3? I've used this slide kind of a number of times. I've kind of refreshed it. DDR2 came out in the early 2001 kind of time frame. Very good product. It's time for a refresh. DDR2 itself peaks out at about 800. There is some suppliers that can get up to 1066, and then some of the gaming companies or performance memory suppliers, using more of a politically correct term, can really push that boundary to higher speeds, maybe even 1200 or 1333. But really, it's kind of peaked out. Its core voltage is at 1.8. So with DDR3, there was a number of things that the industry really tried to focus on. Hey, let's really push the peak bandwidth. So instead of stopping at 1600, twice the bandwidth of DDR2, they're pushing it to 1866, so we're going to get additional bandwidth. They've moved the core to 1.5, and then there's work on at 1.35. So they've looked at a number of different areas. They've improved the signaling, the prefetch, the voltage, and additionally, mobile systems are becoming more and more important. So let's add additional features to the DDR3 architecture itself to help in the power savings. They're using this as a baseline for DDR4. DDR4 is already in the JEDEC committees. It's probably about more than half defined already, and you'll see that product already in prototype phases, probably in the 12-13 time frame. Okay. Now everyone always asks me, well, what's the price? Well, I can tell you Intel doesn't make memory, but Nam Kim from iSupply does a report. This came out in late July, almost early August, so it's a little bit dated, but I did check with him about a week or two ago. The data hasn't changed itself. Two pieces of information that we're trying to show from this chart. First one here is the build plan from the industry. So you can see as they ended last year, they were making about a little over 10% DDR3. As they end 2010, you can see the industry is about 45 to 50% manufacturing on DDR3. So the industry's really ramping up DDR3. From a price standpoint, we have two different curves. Now you look at these columns. We've got kind of buying in very small commodity kinds of orders, or we've got very large customers purchasing in large orders. So we had the price coming down very nicely in Q2 timeframe. But I like to call Q3 the perfect storm. We had a number of platforms from an Intel perspective coming out with that supported DDR3 only. You remember that last slide, we had a desktop product coming out, we had a mobile product coming out, and our server product was really ramping. We also had a number of our customers that were taking last year's chipsets, Eagle Lake and Cantiga, and refreshing them for the holiday buying season and adding DDR3. So if you look at it, we almost had 5 really key platforms coming out in the Q3 timeframe that really drove up the volumes. Well, you guys know kind of economics 101, right? It's kind of supply-demand. If all of a sudden the demand outweighs the supply, the memory industry takes about a quarter to react to that as quick as they can, and you can see it's actually happening. Big spike in supply. Okay? Took me about a quarter to refresh. All the volumes will start coming online in December and November and December, and then you're back in line where it's at. Want to spend just a minute on this. We, within my division, we validate memory to specifications. We take a sampling of the memory from the industry. They send it in to us. We run it through our labs, and we verify that the memory works to specification, both the JEDEC specification, and in almost all cases, we write an additional spec on top of JEDEC with some parameters fine-tuned, some additional parameters that weren't defined at all. So we test that memory to specification. We look at it in a number of different areas. We'll look at it, if it's a registered DIMM, we'll verify the register works to specification. We'll look at a temperature sensor. As these systems go faster and faster, people want to look at how hot the system is. So if I can put a temperature sensor on each of the DIMMs, which was a specification defined by JEDEC, and I can take and react to that temperature sensor. I can turn my fans on faster. Or if things have cooled down, I can turn my fans down, or I can change my CPU. I can throttle my CPU if I need to. So a temperature sensor feature was added. They come in 1 and 2 degrees of sensitivity. Most of the customers for workstation environments are using 2 degrees of sensitivity, and for the server environment, they've kind of defaulted to the 1 degree of sensitivity. So we'll test those temperature sensors. Now, if the DIMM is of a high capacity where you're going to have 36 or 72 DRAMs, you're going to have a lot of DRAMs on there, we have determined that it's probably safest to put a heat spreader on there. So Intel defined the heat spreader specifications, provided that information to the industry, and then we verify their heat spreader solutions. So you can feel confident that the register is going to work, the DRAM is going to work, the temperature sensor is going to work, and then we put it all together and we test it from a platform perspective. If you're interested or have more questions on this, please tell me afterwards if you're a company that makes one of these components, or if you want to find out a little bit more about the testing at Intel. Now, how is the ecosystem doing? These numbers don't look very big, but there's not a lot of key players in the industry. So there's only a handful of companies that can make DRAMs. Many of them are here in the audience. Many of them have booths downstairs. You can also see them. All of those companies are making DDR3 today. They're in the process of transitioning to an optimized process, or they're already at their optimized process. Typically, that's a 50 kind of nanometer type process. We're testing those guys. We've also correlated with those suppliers, so as they make changes to their DRAMs, shrinking them, making them go faster, they can do a lot of that testing on their own, send us the information, and we can continue to stay in lockstep so things aren't going to be slowed down while those products get tested. We'll also look at the registers. Again, there's not a lot of companies that make registers, so we're working with the register companies and temperature sensor companies. So we're working with all of the key companies to make sure that the building blocks are healthy. We'll show that information on a public website. So after we have tested these products, we'll report it up on the website as we get close to launch. So here's the one that just came up about a week or two ago on i7. So we'll give you a little pictorial picture of it, a little bit of definition of it, and we'll start listing all the information. So it's in alphabetical order. I didn't just change and put ADATA first, but we'll show the DIMM supplier, in this case ADATA. They're using Samsung DRAMs. What is the density that we tested, the CAS latency, the part number. We'll give you as specific information as we can so you have a level of assurance that that specific product worked on our chipset. Now, can I guarantee it's going to work on your motherboard? I can't give you that level of guarantee, but we worked it on typically a CRB. The next step that Intel does is we work with leading companies from a motherboard standpoint. We, Intel Make Motherboards, will have a website that lists the motherboard specifically, what motherboard and what memory has been tested on that.